All right, here we go. Welcome to week 2 of semester 2. So we are looking for the scale factor. I'm gonna move this. Okay, hopefully this is a little better. And we're looking for the scale factor. Okay, so we're going to look for corresponding parts, and this time it's based on the appearance. Sometimes it's not based on the appearance, but we can see that the 25 and the 30 go together, the 15 and the 18 go together. So how can we find the scale factor? Okay, so type in the scale factor. I'll give you a hint. It's going to be a fraction. So you can type, for example, if it was 1/2, you could just type that in. Okay, so does anyone have a guess as to the scale factor? And it doesn't have to be reduced. We can reduce it together. So what is my first step? Anyone have a guess? Scale factor? Let's do, what does it say? Small to large. Okay, small to large. So I'm going to put 25 over 30. Yeah, and I'm going to reduce it. Both of these are divisible by 5. Okay, so what is the final scale factor? Five over 6, or 5 to 6. Sometimes scale factor we put using a colon. Okay, so that is scale factor, and it told us small to large. All right, we're going to go on to the next one. Solve the proportion. Does anyone remember what method we used to solve this proportion? We use the method of cross multiply. Okay, so we're going to cross multiply. So we have 10 times b is equal to what? $36. Yeah. And what is the next step of solving this equation? Divide by 10. Okay, so we cancel those. B equals, we can say 36 over 10, which would reduce, we can divide them both by 2, 18 over 5. Welcome, everyone. Let's see. Hello, welcome. I love it that you guys say hi to me. Okay. Or, so you could say 18 over 5 or 3.6. Okay. Now, something to remember, show your steps. Okay. So if you don't have to show that part. But if you don't put all of this and then just put 3.6, you're not going to get full credit. Can you guys hear me? You know what, David? I think it's your volume. Yeah, I think you guys can hear me, right? Can everyone else hear me?
I can hear you.
You can? Okay.
I do.
Okay. So, David, I think it's your computer. Your volume is you're somehow off. And I don't know what to do. Anyway, back to this. Okay, Okay, I better type that in because if you can't hear me, hold on. Okay, that was really funny that I told him verbally that I think it's his volume. That was, oh, perfect. Awesome. Yay. Okay, so do not just put the answer. Yeah, show me your steps. Okay, show me your steps. Now, this is good too, but you don't have to put that part. Okay, the part that looks like a little atom. Okay, find the missing length. Now, I was just grading some of your work from last week. Now, not necessarily you guys. Okay, the people that are attending tend to write out all the steps, but there are people that are not showing the steps. Okay, so do not just put answers. Okay, show your steps. Because would it be a very good Zoom session if I just said, okay, 30 and moved on? No. Show your steps. Okay, so we need to write a proportion. Okay, because the triangles are similar. Yeah, which means the sides are in proportion. Okay, so AM. Now, this time, because we're given the similarity statement, we are not just going by how it looks. So AM is going to be in proportion to AB. Okay, because it says so in the similarity statement. AM and AB, and then we're going to have AN with AC. Awesome. Okay, so yeah, anyone else type in? We have, I'm going to put an X here, X over, oh, you could do it that way. Yeah. Okay, so there's two we could do. X over 40. Yeah, that's the small. Okay, what would have to go there? What goes with the X? Yeah, see how it's the red? Does everyone see that 48 must go there? Oh, you're ahead of me. You're ahead of me. You're awesome, but you're ahead of me. Yeah. Do you see how I went red to blue? Now we're going to go to the larger one. And I'm going to go red to blue. Okay. Or you could do it this way. You could go small to large. You could go X to 48. Then back to 40 over 64. Now, how is it that both of these proportions, I'm going to erase this, make it a little less cluttered. Why is it that both of these proportions will give the correct answer? Yeah, like for this one, I did red to blue. And this one, I did small to large. Why, can anyone see why both those proportions? Yeah, it's kind of the same, just flipped. Is there another part of the answer that tells you that they're going to be the same? How about they're still across from each other? Can you see that both of these, as long as you line them up correctly and you have a method for lining them up, both of these will still give you 64x is equal to I don't know. 64x is equal to, yeah, let's write that. You're right. 48 times 40. Okay, good point. So 64x, and that is 1,920. Yeah, see how we cross multiplied? And now we have an equation. What is the last step of solving this equation? Awesome. Yeah, divide. So x is equal to 30. Okay, so just remember, show your steps. Thank you. And thank you. You guys are doing a great job of participating. Okay, don't forget, I just need to see when I look at the transcript, I may not see that you're participating in the chat at the moment, but when I look back at the transcript, I can see that you participated in the chat, even though I may miss it at the time. Okay, so when you are turning this in, show these steps, please. Okay. Now we're going to find the scale factor again. We're going to write a proportion, write a ratio. Yeah, and I need a pair of corresponding sides. So what pair should I use? All right, we have a vote. Anyone else? Don't forget, everyone type in so you can get extra credit for attending. Yeah, anyone else? Oh, and we need to check. We're going to go small to large. Okay, so you're correct. We're going to flip two of you. Okay, so we're going to do this one. I'm going to highlight them red. These are corresponding. So I'm going to go small to large. Okay, so, oh, good question. How about these? Yeah, can I also say 6 to 9? I cannot say 6 to 9. Can you see that 6 would have to correspond with that one? You can't just grab. Yeah, you guys are great. You cannot just grab the 6 and the 9 because they are not on corresponding parts. Okay, so we're going to say 8 to 12. We're going to reduce that. We're going to divide by 4, and it's going to give us 2 to 3. Or you could put 2 to 3. You're going to see both answers. Yeah, love the participation. Okay. Number 5, we're going to prove that they are similar. Okay, so we're going to get into a little bit of proving. So how are we going to prove these are similar? We could say angle, angle. Okay, 2 angles of one congruent to corresponding angles of the other. We could say side, 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 but this is triangle similarity, not congruence. So the sides are not congruent to each other. The sides are in proportion. Or there's one more. Side, angle, side. 2 sides in proportion, and the included angle is the included corresponding angles are congruent. Yeah. Oh, good point. Okay. I wish I had. Now we could kind of do it. Oh, okay. Good point. I like this. Okay. Watch well, that looks like equilateral. So let's do this. As I make this triangle bigger or smaller, can you see that the angles are remaining the same? Very good comment. now focus on the angles. The angles are staying the same as I make the triangle bigger or smaller. So excellent, good point. If two pairs of angles are congruent to corresponding ones, we know the third one is, right? Because the sum of three angles equals 180. So I could say angle, 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 but because I could always find the third angle, I'm just going to say angle, angle. Okay, enough of me talking. Here we go. Prove that the triangles are similar. Okay, prove that the triangles are similar. Now, I'm going to say this angle congruent to this angle. I'm going to call it angle 1 and angle 2. Angle 1 congruent to angle 2. Why is that? Thank you. Vertical angles. Ding, 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 ding. Okay. So we have these are congruent, right? That's given. Now, why can we say the triangles are similar? So we're gonna write our similarity statement here. Triangle M U N similar to triangle. So what angle corresponds with M? All right. V, M and V go together. U and U go together. And N and W. So there's my similarity statement because what is the reason? Angle, angle, side, angle, side, or side, side, side? Angle, angle. Yeah, do we see it's angle, angle? Okay, so that's how we're gonna do the little proof. Okay, and at the end, we're gonna choose one of those. Angle, angle, side, or side, side, side. Okay. Okay, you ready? This is a hard one. First of all, they are overlapping, so I am going to separate. So this is 42, this is 36. No, this is not 36. How much is this right here? How are we going to get the measure for this right here? It's not 36. Are we going to add, subtract, multiply, or divide? Oh, sorry. I almost just went with it. It's not divide. No, it's not divide. We are going to subtract, right? If the whole thing is 42 and this part is 36, there we go. That leaves, now, do you see how much better for your brain it is to guess? Even if you guess wrong, it's engaging your brain and you're going to remember it longer. So you guys are great. So we're going to take 42, subtract 36, and that leaves 6. Okay, obviously not drawn to scale. Yeah. So keep in mind, when you make the scale factor, we do divide, huh? But when we're finding the missing part, we subtract. Okay, not drawn to scale. Do not let that bother you. So the small one is 6. Do we see why that is 42 and not 36? We're not using 36. 36 is not the edge of a triangle. Okay. So I need this right here. Right? So I'm going to take 77 minus 66, which is 11. Okay, so I have 6 and 42, and I have 11 and 77. Thank you. You guys are great. Okay, so I want to see, can you tell which of these you're going to use? Angle, angle, side, 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 angle, side. Can you see that I don't have the third pair of sides? I can't use that one. Ding, ding, ding. Okay, do you see it? Do you see the overlap right here? Okay, hopefully you can see that this is side angle side, but I haven't proven it yet. Do you guys want to do small to big or big to small? We have to write our proportions. Yay, thank you. Okay, let's do small to big. 6 over 42, is that equal to 11 over 77? Yeah, I have to write a proportion and see if they're equal. Is 6 to 42 equal to 11 to 77? What do you think? Yes or no? Yeah, these both reduce to 1/7. So side, angle, side. Awesome. Two pairs of sides reduce to the same fraction, which means they are in proportion. And the included corresponding angles are congruent. Alrighty. Next. Let's draw them out. So this is VWU, and this is KLU. Okay, so I have a pair of corresponding angles congruent. Now, this is 42. I don't have, oh, I do have that one. That one is 14. It's tricky. This is 6. Now, WU. I need the length of the larger triangle, WU. So so 15 and 6, am I going to add, subtract, multiply, or divide? Ding, ding, ding. Correct. Anybody else? Ooh, not this time. I am going to add them. Yeah? Because we have part plus part is going to be whole. So that is going to be 21. Okay. So I have 621. Oh, and you know what? Oh, am I wrong? You guys, I think I'm wrong. Oh, you guys, I'm so sorry. The 14 goes there. This is not 14. Okay, I'm going to move that. That does not look very good. This is 14. Okay, so my bad. What is this right here? What am I going to do to get, yeah, you guys were like, what is she doing? What is she doing? You guys knew ahead of me, huh? So I'm going to take 42 and subtract 30. This, my friends, is 12. Sorry about that. So this is 12. All right. And then we have 49 and 14. Okay, we have all our pieces. Now, the next thing I want to do we want to go small to big or big to small? I want to see if all three of those reduce to the same fraction. Personally, I'm more comfortable with small to big. Oh, you could go big to small. You could do either one. If you do small to big, you can easily reduce it on the calculator, which I can show you next time you're here. Okay, so let's do corresponding ones together. 12, you can do big to small. I'm going to do small to big. 12 goes with 42. 6 goes with 21. 14 goes with 49. Okay, 12 and 42 can both be divided by what? What is the greatest common fact? All right, 6. And we get 2/7. Awesome. You guys are doing a great job of participating. Okay. Okay, 6/21. 6 and 21 can both be divided by what? 3. Up 2/7. Looking good. Okay, 14 and 49 can both be divided by what? 7. And we get 2/7. We have 3 pairs of corresponding sides, all reduced down to the same ratio, all have the same scale factor. So we say triangle, we go small to big, KUL is similar to triangle VUW because of, and this is what side is. Yeah, we have 3 pairs of corresponding sides that all reduce down to the same scale factor. So yes, they are similar. Okay, kind of like a proof, kind of like first semester, but just kind of more mathiness in it. Yeah, we good on that one? Side. I kind of like that one. I don't know, at the end, when you reduce it and you get 2/7 for the third time, you're like, yeah. Ding, ding, ding. Okay. I like that one. You don't have to like it. Okay. Number 8. Let's focus. I may be the one that needs to focus. Sorry, it looks like scribbling. Okay, let's take a look at this. Jenny wants to measure the height of a tree. She sights the top of the tree using a mirror that is lying flat on the ground. The mirror is 20 feet from the tree and Jenny is standing 8 feet from the mirror. Shown in the figure. I didn't give you the figure. Sorry. Her eyes are 5 feet above the ground. How tall is the tree? Now, what I need for you to do is I need for you to choose the figure. Okay, read this problem. This is the hardest part right here. Read this problem and tell me which diagram represents the word problem and vote, please. This is the hardest right now. Which diagram? Is it A, is it B, or is it C? Okay, Jenny wants to measure the height of a tree. She sights the top of the tree using a mirror lying flat on the ground. Okay, I have one vote. Yeah. She's looking down at the mirror. Oh, you're correct. She's looking down at the mirror and sees the reflection of the tree. Awesome. Now, I know this is hard because we haven't done any yet. The correct answer is B. Okay, so this is the hard part, reading it and being able to visualize what the diagram looks like. Okay, so now we're going to put the numbers in. The mirror is 20 feet from the tree. So this one must be the tree, right? I was always really great at drawing. Oh, actually the top of the tree. Okay, you know what I mean. There's my tree. Okay, the mirror is 20 feet from the tree. And here is Jenny. Her eyes are 5 feet above the ground. Yeah, you with me? Jenny is standing 8 feet from the mirror. Now, the cool thing is okay. Okay, I'm glad you told me that. Can you tell me which part is the most confusing? Like, do any of the numbers make sense or all of the numbers don't make sense? Okay, let's go over this again. The mirror is 20 feet from the tree. This is the mirror right there. Okay. Okay. That is very honest. Thank you. So we're gonna get used to these because we're gonna see the same problems over and over. Okay. So the mirror is 20 feet from the tree. Now, this is really cool. If you take a mirror, now when I was in the classroom, which was actually way back before I had kids, and my kids are like in high school now. We actually did this. We took a mirror out and like you could see, you look down and you keep moving until you see the top of the building. It's really cool, actually. So because of reflection, now you could ask your science teacher why this works. I'm not going to go into that. This works. Okay, so the mirror is 20 feet from the ground. Jenny is 8 feet from the mirror. Do we see that that's right there? And her eyes are 5 feet tall. Okay. So using this mirror. Now, on a scale of 1 to 10, I'm really hoping that this makes sense. And right now you're at a 5. Yeah. Are we at a 5 as to what's going on here? Because as we practice, you're going to get better. And as you do, okay, good. Okay, what is the height of the tree? I'm going to put my X right there. Yeah. So now we need to write a proportion. Now with this one, the easiest proportion, can you see that it just kind of lends to X over 20, 5 over 8? Yeah. Can you see how the proportion just comes right out? Small, or it's like vertical to horizontal, vertical to horizontal. Awesome. All right. Thanks for hanging in there. And what do we do next? All right. Cross multiply. Yeah. So 8x is equal to 20 times 5. Awesome. Thank you. 8x is equal to 100. Now, in showing your steps, you could just go straight to 8x equals 100. You don't have to put 20 times 5. but you're showing everything else. Okay, divide by 8. And this time we're actually going to get a decimal. Okay, so x is equal to 12.5 feet. The tree is 12.5 feet tall. 12.5 feet tall. Yeah. So this would be really cool if you like actually tried it. Yeah. Which I know feels like embarrassing, but it's really cool. Okay, let's do another one. Tommy wants to measure the height of a flagpole at school. He is 6 feet tall and casts a shadow 12 feet long. At the same time, the flagpole casts a shadow 65 feet long. How tall is the flagpole? Zoomer moment. Yeah, Zoomers. That's right. Zoomer moment. You guys are great. Okay. Anyway, you guys, for a moment, I thought I was going to be alone because you guys all came in at like 10:33. I was like, really, I'm just going to go through these all by myself. All right. I love it when you guys show up to Zoom. Okay. Here's the hardest part right here. Okay. So we have Tommy, shadow, flagpole, shadow. Okay. I want everyone to guess. Oh, hold on. First, guess which picture. Okay. I like that you can already see the proportion because, I like that. Okay. But I also need, nope. I also need for you, no, ding, ding, ding. Okay. So this might be good to make flashcards. Yeah. The answer is A. Okay. So let's take a look at this. Okay. So we have Tommy. Oh, no, yeah. Tommy and shadow. And we have flagpole and shadow. Yeah, does it make sense that it was A? Tommy, shadow, flagpole, shadow. Yeah, kind of, sort of. On a scale of 1 to 10, are we at a 5? Hoping for a 5, but practice. Okay, now some of you can already see the proportion. So Tommy is 6 feet tall. His shadow is 12 feet long. The flagpole we don't know. Yeah, and its shadow is 65. So we go and we could see the proportion fall out of the picture. X is to 65 as 6 is to 12. Yeah, not too bad. Okay, so we have mirror, we have 2 shadows, and then we're going to have a third type. Okay, next step, cross multiply. Now this just kills me. I'm going to reduce this. Yeah, you don't have to reduce. X over 65 equals 1/2. 2x is equal to 65. You didn't have to reduce. You could have just cross multiplied. Divide by 2. X is equal to 32.5. I can't believe I peaked. I could have done that in my head. Yes, thank you. Okay, so notice type number 1, we are going to call the mirror. Yeah, the mirror one. So when you see the mirror, that's your picture. Type number 2, two shadows. Two shadows, that's your picture. Okay, are you ready to do a challenging one? Yes, we can. Yes, we can. Okay. You're like, well, I can guess. Okay, Trinity is 5.5 feet tall. She wants to find the height of a tree in her backyard. From the tree's base, she walks 8 feet along the tree's shadow until her shadow exactly overlaps the end of the tree's shadow. Okay? The shadows are overlapping. She starts at the base. She walks out until, there you go. Until, yeah, their shadows are overlapping. So when you see overlapping shadows, there's your picture. Okay, overlapping shadows. Now, can you see that you being here in Zoom and guessing is so much better for your brain than just watching a video? Okay, so glad you guys came as we introduced these challenging word problems. Okay. One more time. No. Ooh, that was a funny little voice, wasn't it? Okay. So now Trinity is 5.5 feet tall. Here's Trinity. There's Trinity. Yeah. Trinity is 5.5 feet tall. From the tree's base, she walks 8 feet. Yeah. From the tree's base, she walks 8 feet and stops. Are you with me so far? Okay, so she stops. Her shadow directly overlaps the tree's shadow. She is now 6 feet from the end of the shadow. Yeah, 6 feet. Right here. How tall is the tree? Ah, yes. Okay, so we have a little overlap. We draw them separately. We have 5.5 and 6. We have X. Okay, big question. What are we going to do to find the length of that base? Add those numbers, awesome, or subtract. By the way, I love that you're doing direct message because if you give me the right answer, it still gives other people a time to think. Ding, 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 correct? Anyone else have a guess? We are going to add them. So this is 14. Yeah, add them. 8 and 6 is 14. Okay, now can you see the proportion fall right? Awesome, thank you. Fall right out of that. Yeah, now it doesn't matter. I like to have the X on the top of the proportion, but it doesn't matter. Okay, so what do you think our proportion is going to be? How about 5.5 to 6 is equal to X to 14? Yeah? Do you see that proportion fall right out of the picture? Okay, so 6x is equal to 5.5 times 14. Yeah? multiply 6x is equal to, no, 77. And the last step of solving the equation is divide. X is equal to 12.8. Yeah, Zoomers. You are ahead of me. You had it before me. Yeah, Zoomers. Not too bad. Okay, if you feel completely lost at the end, stick around and we'll do it again. Okay? All right. Now, quick pre-algebra review. How can you add those fractions? What do you need in order to add fractions? Denominator the same. Thank you. So we're going to multiply the bottom by 2. Awesome. If we multiply the bottom by 2, we must multiply the top by 2. Yeah? So 6 over 16 plus 3 over 16 is equal to? Thank you. 9 over 16. Yeah, 9. Now, can we reduce? There you go. No, we don't reduce because 9 and 16 do not have any common factors. Okay, a little bit of review. What does it mean to distribute? What does that mean? Okay, so we're going to multiply. Yeah, and we're going to get what? When I teach pre-algebra, I call this Angry Birds. Okay, so we're going to take 9 times x plus 9 times 7, which is 63. So awesome possum, awesome sauce. The question here, is this done or is there a next step? Done. Yeah, this is, nope, done. Yeah, it's done. There is no, it's not an equation. It's an expression. It is done. So just wanted to clarify that. Okay, combine like terms. Yeah, I'm going to circle my variable terms. So 7x's plus 2x's make, thank you, 9x's. And my constant terms, 5 take away 1 is 4. Done. This is an expression, not an equation to solve. Okay, so just a little review. So you can, some of you will be in advanced algebra next year. Okay, so this is weird. A is 7. C is 3. Complete the table. Okay, so horizontally, they are mixed up, right? There's no pattern. The pattern is vertically. Yeah, so we have 7 and 3. 1, 2, 3, 4, 5, 6. Okay, sorry, I was lazy. I should have made 2 tables. Okay, what is the pattern? Anyone notice? 4 becomes 7 and 0 becomes 3. Did we add, subtract, multiply, or divide? And how much? assuming it's linear, ding, 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 we added 3. Awesome. Yeah, so we added 3. So going down, we added 3. Okay, so 1 plus 3 is 4. Yeah, now we can complete the table. 3 plus 3 is 6. So that's how this works. It is a vertical pattern. Horizontally, they are mixed up. 6 plus 3 is 9. 2 plus 3 is 5. 5 plus 3 is 8. Negative 1 plus 3 is 2. 6 again. Nah. Done. Yeah. Okay. New problem. A is 8 and C is 6. Wrong. Oh my goodness. D is 6. Oh, I need to change that. That's a D. Yikes. All these years, I always say I'm going to change it and then I forget. D is 6. D. I swear I'm going to change it today for next year. Okay. A is 8, D is 6. Now it's a different pattern. Okay, what are we doing? 4 becomes 8. 3 becomes 6. Ah, ding, ding, ding. Very good. Who else has an idea? Nice. Yeah, anyone else? 4 becomes 8. 3 becomes 6. I'll give you a hint. 5. Can anyone tell me what 5 becomes? All right. 10. Yeah, 5 becomes 10. Do we see the pattern? The pattern is multiply by 2. The first one was add, this one's multiply. So this would become 2, 0, right? 0 times 2 is 0, 12, 4, and negative 2. I need to clean up this problem. And yeah, as we say in Spanish class, ya es todo. That's it for today. Thank you for joining me. 11:29. Ooh, nailed the timing, didn't I? Yeah. Okay. If you guys have any questions, if there's anything you need to see again, yeah, let me know. Stick around. Any questions, even about submitting papers, grade book, anything, stick around and we'll chat. Otherwise, we are done and I will see you. I'm going to say see you. See you next week. Can you see question 1? Yes. Yeah. Thank you for joining me. And everyone remember, show your work. I know that's the most annoying part about math. Show your work. Set it up. Show your equation. Bye-bye. Thanks for coming. Thank you very much. You guys were great today. Okay, so question. You will be submitting this under TK2. Okay, you get the extra credit for joining and participating in the chat. So as long as I look at the transcript of the chat and your name shows up and you participated, yes. So you should go. It should be a line in on Friday of the modules saying extra credit for joining the review session. If not, send me a message and I will add. Okay, I'll put it there. So, yes. Yes, so I will put it there. So you can get the extra credit. Okay, and you just type in that you did it. Any other questions? Okay, you're welcome. Thanks for joining me. Any questions? Oh, yes, question. You can either type in or you can unmute and you could talk to me if you want to talk to me. Yeah, are we good? Yes, ideally try to get here at the beginning, but you are fine. You're fine. Yeah. Okay. You're welcome. Thanks for coming. William, do you have a question for me? Yeah. Do you have a class? You couldn't come at 10:30? Any questions? Anything? So William, there will be a video that you can watch. Okay.
Yeah, sorry, it wouldn't. I was giving me the recording, so I didn't unmute. I just misread the time. I thought it was at 11:30. Now that I'm looking at it, I just misread my time.
Okay. So next week you'll be able to join us?
Yeah,
Great.
I'll watch
Great.
the video now that I realize I missed it.
Awesome. Okay, William, then we will see you next week.
All right, bye.
Okay. Have a good week. Bye-bye.